Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Mathematics paper 4-3 for May-June 2023 for questions 1 to 4. Question 1, two particles P and Q of masses 0.1 kilograms, then 0.4 kilograms respectively are free to move on a smooth horizontal plane. Okay, particle P is projected with speed 4 meters per second towards Q, which is stationary. After P and Q collide, the speeds of P and Q are equal. Find the two possible values of the speed of P. Now, here we have to look at two situations. Since P is lighter than Q, it is just 0.1 and Q is 4 times 8. When it hits Q, it can move forward or it can move backwards. Okay, so those are the two that we are going to consider. So I have here my P, then I have my Q here. This one is 0.4 kilograms, this one is 0.1, and then UP is equal to 4 meters per second projected forward towards this Q, which is stationary, so its initial velocity is 0. And then after collision, we want to get VP. So this is P and then 0.4 kilograms. Then this is VQ, which is equal to V. They have the same velocity after collision. Now, let's consider, I said when P collides with Q, when P collides with Q, it can move forward or backwards. Okay, since it is lighter than Q, since it is lighter than Q. Now, let's consider P going forward. We are going to use the principle of conservation of momentum, where momentum before collision is equal to momentum after collision. So MP UP plus MQ UQ is equal to MP VP plus MQ VQ. Now, mass of P is 0.1, then times the initial speed is 4. For Q, it has 0 momentum because it is stationary. And then, since they have the same velocity V, I'll just add the masses. Here 0.1, then add on the 0.4, then V. So this will be 0.5. Here we have 0.4, and I will divide by 0.5 to get V. So for this case, V is equal to 0.8 meters per second. And then I also consider P bouncing. Okay, P bounces or moves backwards. So we again substitute. We shall have 0.1 times 4, then plus again 0. This one is equal to, now we shall have mass of P is 0.1, but the velocity of P now will be a negative because it is moving in the opposite direction. Okay, remember in momentum we use velocity, not speed. Velocity is a vector quantity, so this, I mean, the direction is very important here. So this is 0.4. Then we can equal to this one is 0.4 minus 0.1. That one will give us 0.3 of V. So meaning 0.4 divided by 0.3 will give us the V. So V is therefore going to be equal to 4/3 meters per second. So those are the two possible values for the speed of the particles after collision. Question 2. A car of mass 1,500 kilograms is towing a trailer of mass m kilograms along a straight horizontal road. The car and the trailer are connected by a tow bar which is horizontal, light and rigid. That means its mass is not considered in this case. There is a resistance force of F on the car and the resistance force of 200 newtons on the trailer. The driving force of the car's engine is 3,200. The acceleration of the car is 1.25 meters per second and the tension in the tow bar is 300. They want us to find the value of M and the value of F. So I can have my diagram here. Maybe this is the car here. Okay. Then there is the tow bar here and it tows a trailer. So in here there is tension that takes this tow bar, the trailer forward. Same tension pulls the car backward. Then there is a resistance force of F on the car. And this is our trailer. Then there is a resistance force of 200 newtons on the trailer. Then there is a driving force of 3,200 newtons. Okay. Now we are given the tension as 300 newtons and then acceleration also as 1.25 meters per second squared. Now we are supposed to look at the forces that are on the trailer alone, and then we also look at the ones on the car. So let us look at the forces that are acting on the trailer. So we are going to use F is equal to MA. Now the net force that takes the trailer forward, we have the tension, then minus this one here. So the tension is already given as 300. Now minus 200, this one will equal to the mass of the trailer is M. So we shall put M, then times A, which is 1.25. So meaning M can be equal to 300 minus 200, that is 100. Then we divide by 1.25. Okay. 1.25. 1.25 is the same as 5 over 4. So if I can have 100 over 1, then times 4 over 5, this one goes here 20 times. So meaning this one will give us 80. So M, the mass of the trailer, is therefore 80 kilograms. As simple as that. Then now we can go to the forces that are acting on the car. Then this one will help us to find the F. Okay, so look at the forces acting on the car. We have the driving force, then minus these two forces. So we shall have 3,200, then minus the tension, which is given as 300, minus F, then is equal to the mass of the car, which is 1,500, times the acceleration, which is 1.25. So meaning here we shall have, of course, 3,200 minus 300. This one will give us 2,900. I will take this one this side. Okay. That will be, so it will become a minus 1,500 into 1.25. This one will give us the F. So simplifying everything in the calculator, our F becomes 2,900 minus 1,500 into 1.25. It gives us 1,025. So F is equal to 1,025 newtons. So that is that. Number 3, a smooth ring R of mass 0.2 kilograms is threaded on a light string. The mass is negligible for the string, okay? The ends of the string are attached to fixed points A and B with A vertically above B. The string is taut and the angle ABR is equal to 90 degrees. The angle between AR and the string and the vertical is 60 degrees. The ring is held in equilibrium by a force of magnitude X newtons acting on the ring in the direction perpendicular to AR. Okay, then we are told to find the tension in the string, and the value of x. So since this is the string here, there will be the tension in that string there. So we put tension, and then this ring here is going to have its weight acting downwards, which is 0.2 g, okay, mg. And then I'm going to extend this one here. Then I put this one here, okay. I'm going to resolve the forces. So closing is cosine. So that means this one will be x cosine, okay, x cosine of an angle which is here. So let us find out which angle is this. If this is 60 here and this is 90, that means the angle here is 30 degrees, okay, because 30 plus 60, that is a 90 plus a 90, then you get 180, since this is a triangle. And if I have 30 here and this one is 90, that is 120, then this one here must be 60 degrees, okay, such that those are angles on straight lines. So this is 60 degrees, so that means here I'll have 60 degrees. And then I will also resolve it up here, okay. When I put it up here, then it will now be x sine of 60. Opening is a sine. Then I will also resolve. It's like I will detach this one from here, then resolve it here, okay, something like that. So this will be closing, so I will have t cosine of 30 degrees. And then I will also open it here, then it will be t sine of 30, t sine of 30 degrees. So those are my forces which are acting on the ring. Now, resolving forces horizontally, since the system is in equilibrium, okay, then there is no resultant force in the horizontal and the vertical. In other words, the forces going this way are equal to the forces going this side, okay. So we are going to have x cosine of 60 degrees is equal to and by the way, there is tension here, since this is the ring, I mean the string, and this is a string, then this is the ring here. So the same tension up here is also up in this string here. So we shall put tension also there. So there is tension here. So that means horizontally we are having this force here equal to these ones here. So we shall have t then plus t cosine of 30 degrees. Okay, then cosine of 30 is of course a half, so we shall have a half of x, which is equal to, I can say t here is common, then I factorize it. Cos of 30 is root 3 over 2, okay. All right, then I can actually write this as x over 2 can be equal to t inside here, maybe 2 plus root of 3 over 2, such that I kill this 2 on both sides when I multiply all through by 2. So this will therefore mean that my x is going to be equal to t into 2 plus root of 3, okay. I can keep this as my equation 1. Then how about when we resolve forces vertically? When we resolve forces vertically, what do we see in the diagram here? We are seeing these forces here equivalent to the weight down here. So I'm going to write t sine of 30 degrees plus x sine of 60 degrees. These are the forces going up, and is equal to the weight, which is 0.2 g. Sine of 30 is a half, so we have a half of t, then plus our x is 2 plus root of 3 of t, right from here, okay. Then sine of 60 is root 3 over 2, then which is equal to, here we shall have a 2. You see that? Now this simply implies that we can multiply all through by 2. If we multiply all through by 2, we shall eliminate the 2 in the denominator. So we are going to have t, then plus 2 plus root of 3. Then let me also put this root 3 here, then t, then is equal to 4. Now t is common, I can factorize it. 1 plus 2 plus root of 3 of root of 3, then is equal to 4. Then making t the subject, now our t is going to be equal to 4 out of 1 plus root of 3 into 2 plus root of 3. Okay, now we put this in the calculator. 4 out of 1 plus root of 3 into 2 plus root of 3, and then it gives us 4 minus 2 root of 3. 4 minus 2, you can even leave it exact, you'll still be marked correct, or to 3 significant figures, 0.536. So I can write t is equal to 0.536 newtons. And that is that. Number 4, a lorry of mass 15,000 kilograms moves on a horizontal road in a direction from A to B. It passes A and B with speeds 20 meters per second and 25 meters per second respectively. The power of the lorry's engine is constant, and there is a constant resistance to motion of magnitude 6,000. The acceleration of the lorry at B is 0.5 times the acceleration of the lorry at A. Part A, show that the power of the lorry's engine is 200 kilowatts, and hence find the acceleration of the lorry when it is traveling at 20 meters per second. Now, I'm going to sketch something small here. You know, I love sketching in mechanics here. It helps you understand the context within which the question has been set. You can easily know the forces that are acting on the particle. Let's say this is the car here. It has a resistance force here of 6,000 newtons. Now it can move from this part here. Let's say this is point A, then this is point B. Okay, so when it reaches here, still it has that resistance force. The velocity here is 25 meters per second. The acceleration here is 0.5 of A, and the acceleration here is A. U here is 20 meters per second. Now, we know that power is equal to the driving force, okay, then times the velocity. So let us look at point A. We have the driving force which is going forward. So that driving force is equal to power over the speed, okay? So power, which we don't know, over the speed, we know it as 20, then minus the 6,000. Remember, we are going to substitute in F is equal to MA. So minus 6,000, then is equal to, the mass of the car is 15,000, then times the acceleration, which is A, okay? Now, we can multiply all through by 20, okay? When we multiply all through by 20, our P here is going to be equal to, actually, let us first take this one here so that it becomes a positive. So we get 6,000, then plus 15,000 of A. Then after that, multiply all through by 20. You see that? That is now equation 1, okay? Then let's go to the next one. At B, what is happening there? Again, the driving force is going to be, we have our driving force here. So driving force is going to be power divided by, now the speed is 25, then minus again 6,000, which is equal to 15,000. The acceleration is 0.5 of A, okay? Now take again the 6,000 this side, and it becomes a plus. Then after we multiply by 25. So meaning P shall be equal to 6,000, then plus a half of 15,000 is the same as 75,000. So we can have 75, actually 100, not 1,000 of A. Then now we are going to multiply this by 25. This is equation 2. So since all of them are equivalent to P, this simply implies we can equate them. So 20 times 6,000 then plus 15,000 times A then is equal to 25 into 6,000 plus 7500 of A. And then we simplify. So when we open the brackets, this one will be 2 times 6, that is 12. And then we can put the 4 zeros, then plus 2 times 15, that is 30. Then we can put the 4 zeros. Yes, I think it is like that. Then of A. Then when we come to this side, 25 times 6, 25 times 4, you get 100. Then you add on two 25s, so that is 150. So we get 150. Then we add on the 3 zeros, then plus 25 times 7, 500. That is 1875. 187,500 of A. Now I can bring this one this side. I can take this one here. In other words, we collect like terms to solve this equation. 300,000 then minus 187,500. That is 1125. Then 00 of A. 112,500, okay, of A then is equal to 150 minus 120. That one will give us 30,000. Okay, 30,000. So meaning acceleration is going to be equal to 30,000. Then we divide by 112,500. So what do we get here? 30,000 divided by 112,500. It gives us 4 over 15. So 4 over 15 meters per second squared. So since this one is not a terminating decimal, I can choose to leave it there. And then next is to find the power. Okay, so I can substitute in any of these ones, either this one or this one here. Okay, because they say that show that the power of the lorry's engine is 200 kilowatts. So let us substitute maybe in this first one here. So any you want, power is going to be equal to 20 into 6,000. Okay, then plus 15,000 of A, which is this one here. And this one will give us, we have 20 into 6,000, then plus 15000, then divide by 15, but then we have to multiply this by 4. So we get 200,000. And that is what we were supposed to show. So this is 200,000 watts, but divide by 1,000, then it will be 200 kilowatts. As simple as that. Then down here we have the lorry begins to ascend a straight hill inclined at 1 degree to the horizontal. It is given that the power of the lorry's engine and the resistance do not change. Find the steady speed up the hill that the lorry could maintain. Now for the steady speed, acceleration has to be equal to 0. Now I have my sketch here. This car, the lorry, is now moving upwards. Okay, is ascending this hill, so the driving force is there. Then we have this 6,000 newtons. It is unchanged. But again, this being on an inclined plane, there is this horizontal component of the weight, which is mg sine theta. So the m is 1500, okay, I mean 15,000. Then there is g, and then the sine of 1 degree. So for steady speed, acceleration is equal to what? 0. Now using F, which is equal to ma, we shall get the driving force here minus the resistance force is 6,000, then minus also 15000 times 10, which is the g, and then sine of 1. Remember, this one is in degrees. It is a very small angle, so make sure that your calculator is in degrees. Okay, then the driving force, if power is equal to the driving force times the velocity, that therefore means that the driving force is equal to power over the velocity. So the power is 200,000. It is unchanged. Then divide by the velocity we are looking for. Okay, I can take these ones the other side. So I can have 6,000, then plus 150,000, and then sine of 1. Then I can cross multiply. In other words, I'm going to get the whole of this. I divide it by the 200 to get our V. So V shall therefore be equal to 200,000. Then we divide by 6,000 plus 150,000 sine of 1. Okay, sine of 1. And to three significant figures, what do we get? 200,000. Then we divide by 6,000 added to 150,000, I think there are 4, and then sine of 1. Okay, so we shall get 23.2. Okay, to three significant figures, 23.2 meters per second.